This week we have learned about some equations for accumulation, depletion, and inversion. After that, total charge density of MOSFET and CV characteristic was our one of courses for learning MOSFET previously. First, I would like to review about equations for three stages. And for accumulation region, surface potential drop can be neglected compared to flat band voltage. Here, as you see in this equation, what you have to focus on the chart is the charge. Each charge is negative here because voltage that we give on the gauge charge is opposite of the charge that is created in the surface of the oxide and silicon, and that is the reason why its charge is negative. For about depletion region, if the device is MOS, each equation is kind of like that here. What you have to focus on this section is the relation between the gate voltage and depletion width. If we give strong gate voltage, the depletion is gonna increase. For inversion, if the number of the mobile charge is in the body and the number of mobile carrier which is opposite sign at oxide and silicon interface become equal, if then inversion happens. For MOS device, if surface potential is twice bigger than the difference between the intrinsic potential and Fermi potential, each state would become inversion state. The moment as soon as the inversion occurs, we call this moment voltage as threshold voltage. And after that, we have to know about total charge density of MOSFET. As you see in this graph, x-axis is about surface potential and y-axis is the surface charges. We can guess the state by these parameters. For CV characteristic, if DC voltage is smaller than the flat band voltage, it would be accumulation state. Here, if the DC voltage is in the range between the flat band voltage and threshold voltage here and here, between them, each state called depletion region. And for last, if the DC voltage is bigger than the threshold voltage here, it will be inversion state here. And inversion state is divided into weak inversion and strong inversion. And weak inversion is kind of like to increase linearly, and strong inversion looks as like a saturation region in the IEV diagram, but it's not the same as saturation because each parameter on the y-axis is capacitance, and voltage is also not the same as the IV characteristic. And to add, the reason why the depletion region decreases here is due to the capacitance which was created during the depletion state for serial As you know, if capacitance are in series, each capacitance would be decreased. That is the reason for why when depletion state, and each oxide capacitance decreases. And also, if we give low frequency, it will be rise from the depletion to strong inversion. But if we give high frequency, which is bigger than 100 megahertz, it will be not increases like this. For next chapter, we mainly learn about MOSFET and its characteristics and channel length modulation. MOSFET is a device which consists of body, drain, source, and gate. And actually it is 4-terminal, but we regard this as 3-terminal devices. As you can realize from its naming sense, source is to give current to drain, and during this process between drain and source, there will be a channel because of inversion when we give bias on gate, and here channel. And more we give gate source bias, the drain current would increase. Here, as you can see in this diagram, if we give more gate versus gate voltages, each drain current seems to increase, and we call this region as triode region here, the linear part. And after a moment, drain current will be stable regardless of the gate source's voltage. And here, it looks like stable, and we call this section as saturation region. And it was my this week's review, and thank you for listening. Thank you.